All right, so history, design requirements, audio, network, microphone, and operational examples, and some of the wish list items here. And then maybe, because we got a connection now that's somewhat reliable, if you want to start testing this and you have an advanced license, which is a requirement in Canada for remote operations, maybe you can work with me and we can get you set up on position 4.
Pretty good, I think, and yeah, it's working fine.
Okay, Al, well, have a good afternoon. We're about 10 or 15 from the North Shore Emergency Management Office there, so we'll drop in there and get our thing done. Talk to you later. Have a good evening, and thanks for the test. I'll be 7 Whiskey Juliet, be 7HHS cell phone mobile here.
Yeah, well, you're not going to drop around before you head home?
Yeah, I will, but that'll be a little later on, okay?
Go 7 Hotel Sierra, cellular phone mobile. This is Victor, Echo 7 Whiskey Juliet. Catch you in a few hours.
That gives me an idea how old.
Okay, 7-3, I'll have a good evening.
So that was before distracted driving legislation. That's how old that video is, and the phone in there is, one of the very first iPhones. So been at this for a while. In fact, I went back into my photo gallery and some pictures of me down here in the late 90s, early 2000s, working on remote stuff, PC Anywhere back in the day, and all sorts of experiments. Basically, since the beginning of ADSL at home, right? When ADSL became available to residential, that opened the door to this world, because before then it was telephony for audio, but you had no way of control unless you did things like DTMF control, and there was all sorts of kits available in the 90s, and still is today for control of your station over DTMF, but that's pretty old school. So back then, of course, we weren't dealing with anything but analog radios. This was before big fancy pan adapters, before SDRs, and so we were really interfacing to the radios of the era. Things like the Club's FT1000D that we used to have, the ICOM 765 that we used to have here, etc. And so the name of the game was really just transporting audio. We were transporting two-way communications, typically over phone lines, and if you were doing it over the internet, it might have been things like TeamSpeak, which was one of the very first kind of conferencing applications, still around. If you were using the protocols back then, you were stuck on codecs known as G711 or G722, and those are both still very active today. Some video on the side here of just testing over the years with different interfaces. I've, like I said, been testing this on and working on this from the analog era all the way up to the K3, and now moving into the SDR world. So from a timeline perspective at the club here, when we rebuilt the club, starting in 2014 from an antenna perspective, one of the things that we did was give a real hard think about trying to make everything IP enabled by default, right? Because we used to manually patch rotators around the station. If you wanted to rotate an antenna at an operating position, you took the control box and patched it in or rewired it to to do that. And just one sec here, and so that's not a lot of fun. So IP enabled everything makes that quite straightforward. And as I alluded to here, the very first testing we got serious with here at the club with the K3 that the club owned was with some software that allowed that to be remotely controlled. Pig Remote was one of the first ones. Pignology, that's funny, a funny name. Ham Remote, I guess. RC4 is still out there. It's a Windows-based application. It's a client-server kind of thing where you basically run an application on a computer full-time that talks to the radio, and then people can remote in and control radios and have a virtual front panel. And then in 2019, when we put the ANAN 8000 into service on position 4, we moved into the whole software-defined world, and that was kind of the beginning of the next generation of this stuff. So that brings us to the design requirements section here, and this is pretty lengthy, and I wanted to spend a bit of time on this because this is fundamentally how we arrived at where we are today. And I'm going to go line by line because I think it's really important. That's why I printed out a copy. First and foremost, because of the fact that we are being heard by every week hundreds of people in British Columbia, we wanted to have the best, the cleanest transmitted signal. There's just so many examples. I'm sure everybody's tuned around the band of spurious, splatter-filled stations with tons of harmonic distortion and poor audio and everything. We've solved the audio problem a few years ago. Pure Signal is probably the best working example right now that the Apache Labs has, which is adaptive pre-distortion. And so I have some pictures of this actually later on in the presentation, the signal compared to others. We typically run on the BCNet, for example, about a 3.6 kilohertz transmitted bandwidth. But when you look at that on the spectrum analyzer next to, I'd say the vast majority of the stations checking in, they're actually wider than we are, because our skirts are so tight on that transmitted signal. You're 60 to 80 dB down as soon as you step outside of the passband we're operating in. And without Pure Signal, it's an easy toggle button. You toggle that off, it's back to like the K3 was, so it's neg 30. That's a substantial difference in the amount of splatter you're sending in adjacent sidebands, upper and below your fundamental.
You had somebody monitoring your transmissions from here, and he was watching it on a scope and got back to you and said it looks good on a scope.
Yeah,
He was a broadcast engineer.
We've had numerous people in the community who have engineering experience, guys who worked in test in labs and whatnot, send unsolicited reports in thanking us for the efforts that have gone forward to making that an example. Right? We're on the air every week. It needs to be top class. And a big part of this is the fact that the compression that we're using in the audio path here is substantial. We're 25 to 30 dB of audio compression. When Roly's talking into the microphone, it doesn't matter if he's yelling or whispering, it sounds about the same on the other end of the air. And there's a whole bunch of things that go into making that possible, which I'll describe later on. So the other fundamental thing, like right underneath priority 1, which is our outward appearance, is the experience for those that are using the technology. So if you are on site here, you have the same look and feel of the screen as you would as if you were remote. That's big, right? Because it means from a training perspective, if you are familiar with how to operate position 4 in the room, it's the same if you were at home. Number 3 is kind of connected to the first two. It's indistinguishable on the far end if you're actually physically present in the room here, transmitting on the radio, or you're remote. We wanted to have that sound exactly the same, right? There's lots of examples, if you listen on the air, of people running remote stations that leave a lot to be desired, right? It sounds remote. Cross-platform, we needed to be able to do this across Windows, Mac, mobile if possible. Ability to power cycle things. When you're running remote stations, it's actually a requirement that you have the ability to have an out-of-band path to shut things down if there's problems. So we have remote power control on the power supply to the radio, the audio mixer, anything that could be involved in sending a signal into the air can be remotely reset, which is cool. And I've used that a few times actually, where we've had things lock up and not necessarily cause a problem on the air, but become unreachable or doing weird things, and it's just reboot, but I can do that from anywhere. Number 6, we're keeping all of the audio in and out of the radio in the analog domain. And this is a bit of a kind of a question. Well, if it's an SDR, why would you do anything in the analog domain? And the reality is that the fastest path into the ANAN and that architecture in SDR is still an analog in on the back of the radio. If you're going in through anything else, you incur about another 50 to 80 milliseconds of delay. And the name of the game is minimizing the delay as much as possible end to end, and that was one of the things. It also allows us to open ourselves up to and to be agnostic for any other audio path coming into the station. If we want to do this over a telephone line, if we want to do it over an analog interface, a 4-wire, whatever it could be, we could do this over because we have an analog connection to the radio. Low latency, right? We wanted to be able to do this with as low a latency as possible. I mentioned I was testing this back in the 90s, and it was impossible to have visibility to a radio and be on the same page with the residential stuff that was available back then. We've come a long way. I have to thank the gaming community for the work they're doing on high frame rate rendering and graphics cards. It's really made things economical. There's a program called Parsec that we use that is free at the free tier that allows you to render a screen remotely in latency that you can't determine that you're a remote connection. It's literally like being in front of the screen, even at 4K resolution, which is awesome, and at 3 megabits per second, which is wild.
What's latency like on that?
Like it's
like 20 milliseconds, something like.
It's the latency. Actually, I'll tell you right now. For example, I'm watching the Yeah, so I'm watching the delay here right now. It's 7 milliseconds to get to the from here to the radio. The rest of it would be the network in between, right? So cross-platform I mentioned. We wanted to be able to record the audio on the PC. So for oftentimes you're doing things on HF, you want to record somebody you're working. Oh, this cool station on the air, I want to record that. We can do that quickly with a touch of a button. We want to play something back to somebody. We can do that. If somebody says something, let's say you're passing traffic or you're getting a call with some really critical thing on CFARS, you could actually record it and have that logged, as a WAV file, play something back on another frequency. That's all possible through a software program that we're using called Voice Meter Potato. It's a really funny name, but Voice Meter Potato is the software we're using for that. Now on this back page, this is pretty dry. It won't be dry this rest of the presentation, but I wanted to go through this because there's 19 reasons we got to what we're doing here. We got to prevent the remote person's audio from coming over the speakers. Oh, sorry. Yeah. We need to prevent the remote person's audio from coming over the speakers, right? So if I'm at home and let's say, for example, Phil's on the radio at the station here, I'm at home, that's a possible combination. We can both be using the radio at the same time. One person obviously could be transmitting at a time, but if that speakers are on in the radio room and the mic is open, you're going to get a feedback loop. So there's a concept of a mix minus built into voice. Mix minus is a terminology that basically allows you to prevent a loop back of somebody's own audio from coming back to them down the line. So remote participants don't hear themselves, and that's something we can configure. We can also mute people at position 4 on this conference software. So let's say somebody forgot and had open mic, we can go in and just unmute or mute them just locally on that radio. Doesn't affect the rest of the conference users. They can all still hear each other, but on that radio, we can actually prevent them from coming on the air, which is another cool thing. Number 14 is 24/7, 365 logging of audio. So anything that's in the headphones of that radio, yeah.
Sorry, going back to that individually, so does that mean that position 4 is going in on the Mumble channel? Like it's in the Mumble conference?
Yeah, it is, full time.
Okay, so it's not, there's no direct connection to the radio from the mic that's at position 4. It's going...
No, the mic, yes, you're partly correct. The mic is hardwired to the system. I'll cover that in a minute. Okay. But the Mumble comes in through the Voice Meter software package. Yeah. And because we're on the Mumble server, we can tell us what users we want to have audio coming from. Like we can just say, I don't want to hear this guy, I want to hear this guy. Yeah. So if you're making noise, I can just mute you, but you won't go on the air.
Okay, but position 4 can be muted? Was that what you're saying? No, position 4 can mute them.
Yes, correct.
Okay, got it.
Yep.
Sorry. Okay.
Okay, 24/7 logging of audio. So it's really important that we have the ability to do troubleshooting, to see what's going on, if there's a problem with things, or let's say you're in a contest and you want to play back something. Out of the box, anything that's in the headphones of that radio, that what an operator would be listening to, or the radio audio or the Mumble audio, remote audio, Windows audio, all that is streamed out of here 24 hours a day, 365 by a box. Now, I've had very good success with a company called Barracks. They've been around forever and ever, make little embedded audio equipment, IP, audio over IP interfaces. And the BC Warren team, mainly Jeff Armstrong, hosts a server at UBC at our head end called IceCast, another thing that's been around forever. And basically it creates a log file for us. Every 15 minutes, we get chunked of audio. We can go back and look at like 4-day history on anything that's come over the air. Okay, number 15, pretty self-explanatory, web-based in control and selection of antennas and direction of antennas, right? You're all familiar with the web UI that we have in the radio room for turning rotators around. You could still physically touch the rotator and move the antenna, but there is a web-based control of that. And that goes back to my 2014 comment around kind of designing with IP in mind from the get-go. And I'm going to thank Keith V7KW for building the Node-RED web front end on Raspberry Pi that we use for controlling the T2, the Tower 2 quad, which I'll show you a picture of later. Local and remote use at the same time. Okay, that all of the above that we've been talking about makes this possible, right? We can have people, and we do this all the time during CFARS. We have 5 or 6 people on the conference listening to the radio, and we can have a person come off mute, and one of the guys can take over control of the radio, get their transmission out. So it's really cool. There's not very many remote systems. Back when I was testing this is a lot of these systems are designed for, I have a radio at my cabin. I'm the single operator. I'm going to connect to my radio at the cabin and that's it, right? There's not a lot of multi-party solutions available, and that's kind of what we've built here. The ability to interface with a future amplifier via a network. So What that means is moving away from clunky physical cabling like RS-232 control between a radio and an amplifier to tell what band. Amplifiers need to know what band you're on so they can track and they can set the filtering accordingly. In the past, that's been done typically over RS-232. Nothing wrong with that. It just means that it's another physical cable interface that is not IP based, that is fixed in its location. You have to have these things connected via 2 cables now. So anyways, the amplifier that I had for a small period of time fit this bill. Maybe at some point we'll get an amplifier back in there that works. So unfortunately, the amplifier was the problem in this particular case. It had a couple of faults. I think most importantly here is no recabling to accomplish any of the above things. So if you want to do anything I just listed, remote participants, ignore the UPS, that's battery that's unhappy. It takes about 3 seconds and it should shut down. 3 or 4 seconds. It came on last night. So no recabling to accomplish any of the above. So if anything, people want to come in remote, want to operate digital modes, want to make a phone pass, like all that can be done without having to rejig any cabling. I said it was going to go quiet. It's going to prove me wrong. Software codec, and the last part is really around audio quality. Just give me a second here, guys. I got to shut this UPS alarm off. Software codec and audio quality. So one of the challenges we have in a remote radios is a lot of the protocols that are developed for voice over IP are generally developed with human voice in mind, in trying to preserve human voice. Think of a cell phone and the noise canceling you have on modern cell phone calls. That's really great until you're trying to preserve static, right? You're trying to preserve static over an HF line, which is really complex because it's white noise. That's murder on a codec, and so you can't have noise cancellation technology getting in the way. You shouldn't have anything with echo cancellation because echo cancellation can interfere with the fidelity of somebody's voice. So, and it has to be full duplex, right? So that's kind of all of this. It needs to be like talking on a telephone. So that's a lot to say, but that's how we got to where we are. I'm going to spend a few minutes here on the audio path because this is kind of where rubber meets the road. And I'll start on the left-hand side here. So you see we have 2 microphones at the station. We have the RE20 and the headset microphone. Both of those go in on analog mic level into a mixer, a standard conventional mixer that is IP controllable. That mixer has an output that feeds in the rack area of the radio room, our audio processing. This device here, this DBX286, is actually primarily doing a function called a noise gate. So what it's doing is it's listening for any audio above a certain threshold and letting that go through. And if, in other words, eliminating background noise, fan noise. And it's a really, really fast attack and fast release. So, and you really struggle to hear it work, which is, I played around with a few different solutions before I landed on that particular processor. That means that you can sit in that radio room and you can talk with fan noise in behind you and it won't make it on the air, despite this device up here adding like 25 to 30 dB of compression. So you need to get rid of the noise before you go into the compressor, right? There's a lot of people who stop talking on HF and their signal strength doesn't change because they have a linear amplifier next to them and all you hear is this inrush of fan noise, and that's just not professional. So we nuke that at the beginning of the chain here. Out of this device up here is an Optimod 9300. We actually have an analog version in the rack as well that I landed on first. But the 9300 is a digital version of that, still shipping product, and it's IP addressable. Not that that really matters because it's just set and forget. These things don't ever be, they've never been touched once they're set up. The primary function of this device is to apply compression in a way that you can't really hear it working too well. I still find most of the amateur radio implementations of compressors, you hear pumping action, you hear lots of AGC, and they can introduce pretty harsh distortion. And the commercial broadcast world and audio processing, Orband's been around, since the 60s, and their cousins do the best job of this. Anan's pretty close with some of the stuff it has in software, but it's still not as good. And I've done A to B testing. So we leave out of that. We come over to the radio, and you'll notice we're going in on a line-in level. line in on analog domain. So that's the Apache Labs ANAN 8000 up here. Coming out of the radio, we leave on analog out. We go back into that audio mixer, and there's a matrix of routing in that audio mixer. I have a screenshot of it in a minute that we send audio to different things. But primarily what we're doing is we're sending it over USB to the computer. We're sending it to the computer, which was running this voice meter software I've been talking about down here. We also, as I mentioned, send it out to a device here, that Barracks in Streamer. And that in Streamer is the 24/7, 365 set and forget, box that just streams everything out to the IceCast server at our head end. It's kind of like the data logger, the black box, if you will, the cockpit voice recorder. Okay, so this is a USB connection down here, down to the computer, and the computer's hosting numerous applications. Primarily, we have Mumble, we have Zoom, we have a phone patch, voice over IP phone patch software called MicroSip. We use Audacity, if you want, or any other program. Audacity is great for recording audio and playing back audio. Let's say, for example, this weekend you're participating in the CQ Worldwide contest and you want to record voice keyer messages like CQ contest, this is blah, blah, blah. You could do that in Audacity, save the WAV file, and load it into N1MM. And then what about digital modes? Let's say I'm playing with WSJT, or I'm playing with Vera HF on Vera modem. I can do digital modes through that same path in. You'll notice that we have some speakers, and these have been really good to us. They're a USB speaker that plugs into the computer. The Bose speakers, there's Film modified them. They sit under the table, sit under the monitor, and the little subwoofer's under the table. And you can actually crank it up quite a bit if you want to listen to some shortwave broadcasts in the evening. So
The station's no longer on the air that you used to listen to all the time.
yeah, exactly.
So single channel audio in and out?
Most of this is mono, but we support stereo out of the receiver because the receiver has diversity capability, right? That is possible.
But just a single stereo channel, basically, on that USB too?
Coming out of the, it's a little more complicated than that. We actually have 16 channels that can come over USB.
Okay, so you can select any one of them if you want.
Yes, I'm only using 4, but it's possible. Now I put all my marks on this. I got to figure out how to clear the screen here. Let me see. I thought I was able to clear this easily with like one button here. Clear all my drawings. Perfect. Any questions on that drawing, Richard?
On the DBX 286,
Yep.
it has compression on there. I have one of those units. They're
Yes,
awesome.
it does.
So why is the Optimod?
Why do we have the Optimod in there?
Because you said it's got the compression, but you're not using the compression on the.
Pretty much, yeah. So the big thing with the Optimod is it does compression, but it also does something called preemphasis.
Oh, okay.
Right. So for those of you not familiar, preemphasis is basically putting a very, very stiff EQ curve with a high boost. For here, it's starting around 1500 hertz, right? So right in the voice band, and it ramps up at 18 dB per octave, which is intense. There's a broadcast standard for this, which I think is 10 dB. Joel, you might remember, it's NSRC standard, right? It's like 10 dB per octave, which is what like broadcasters use to pre-emphasize the high frequencies because of loss in transmission. And that's the problem. If you just hook up a microphone like that RE20 or the headset to the radio and you transmit, you're going to sound all muddy and bassy, and it's just not cool. But once you come out of that equalization, you get a really, really high frequency compensated signal. And I've got some pictures of what that looks like on a spectrum analyzer in a minute here. Any other questions?
The in-streamer, what sort of bandwidth is it using?
16 kilobits per second. Yeah, it's heavily delayed on a highly compressed MP3 feed.
So I guess another dumb question may be, why not do that in software on the ANAN?
Why not do the compression on the ANAN?
Yeah, the compression and preemphasis. I think
It sounds like shit.
Yeah, it wouldn't be as good as these two.
So the software is just not up to snuff.
I've done the testing on that because before I went and spent the money on the Optimod, which costs more than the radio, I was listening to see what the difference was. And with if you turn around NHF in the evenings on a quiet band and you listen to anybody that's running what they call CFC tools, which is the newer compression algorithms they're running for multi-band compression in the Apache Labs radio, you can hear it pumps and it makes some really ringing noises. You hear it's just acoustically doesn't sound natural. It sounds very ringy, like tight filters in a DSP. You get this ringing on the edges. You know, like, you remember the ICOM 7000 microphone problem with the D? It's the same kind of, you hear this ringing to the effect, and it sounds unnatural to me. So,
You think eventually?
would hope so. Well, let's put it this way: the DSP is what they're running in a 9300. If somebody cloned the algorithm they're running in there, in the FPGA,
It has the power.
absolutely, yeah. This is just a lack of attention in that area, right? I think it'll come over time. If you had no Optimod, absolutely, like, fill your boots. It would be 100% better than nothing. Far better than the default compressor in the radio, which has no concept of processing on voice bands. One of the things that the Optimod does and CFC does in the radio, if you had that turned on, is look at your individual frequency bands, like your low frequency, baritone, your mids, your highs, and this particular thing's 5-banded, and it processes it individually and then resums it at the end. So what that means is somebody like Phil has a deep voice, those frequencies don't get all the attention and get dwarf out the high frequencies, which would happen in most compressors. You compress based on the loudest waveform, and now all your other stuff is knocked down.
If you're in the station and you're watching the ANAN there, and you're watching the fish finders, we like to call it, a lot of stations will be like this wide in the audio when you don't need to be. You need to be like right there. So the Optimod gets rid of all that extra area you don't need and puts all the energy right down the middle, right there. The old game in broadcasting, and it still goes on in radio, was to have the loudest, clearest signal you could possibly have using compression and using the Optimod, which is like the standard in broadcasting in every radio station, to try and achieve that. And they're not running at quite 100% modulation. They're running about 98%.
Yep.
And the whole idea is, as you're going through the channels trying to find a worthwhile station to listen to, suddenly it pops out. It's like, wow, they're clear, they're loud. I'm going to lock that one in.
Yeah, and I think a big thing that I think anybody who's got a modern radio like an SDR, you're often chasing signals based on the visual aspect of them on the screen. You know, the days of tuning the VFO without a visual display are kind of fading away. And so human nature is to, who is that signal that is really, the same consistency throughout? It's very tight on the screen. I want to listen to what that guy is. And that's what makes a difference. And I'd argue that in contesting, even I'm in that way. I'm not a serious contest operator, but I will find the signals that on the screen that stand out, get rid of them first, and then move on, right? So.
And then the barracks, for example, is getting the original audio. It's not getting the compressed audio.
Correct. Yeah, absolutely. And that's a part of the routing in that. So this Mo2 analog mixer here, I don't want to belabor it, but this is just some of the pictures of what that looks like. So this is the web interface for it. I mentioned it's a web IP, so you can see we have a ability to mute the microphones, whether you're sitting in front of the radio here or remote. Boom microphone, headset mic. We have a wireless headset, and the remote user is coming in via Mumble here. I'll call your attention to the gate that's in here as well. So we can also gate audio right in the mixer as it comes in. So the microphone, the RE20 coming in, has the ability to have a noise gate right on that microphone coming into the mixer before it goes into the compressor, before it goes anything downstream, which is huge. And this is an eye chart, but this is the example of the routing that's available in that mixer. I can take any input to any output I want. And so that's, again, set and forget. It hasn't been touched in a couple years. Now, this is the brain of the operation on the computer. This is called voice meter. This is what it looks like. It looks pretty complex to the first-time user, but it's pretty simple. The main thing is you define your inputs up here on the top left. And those they're mostly physical inputs. They're things that present themselves to the computer via USB typically. Could be an outboard mixer like the Mo2, which is what we're doing. So you map your inputs there. On the top right-hand side, you map your outputs there, right? So that's where you say, for example, I want to have my Bose speakers going out on this particular bus. These are your physical output buses. You have 5 output buses you can work with. A bus is basically a summing channel, so I can send anything I want to an output. And then you have virtual outputs, which can be used by software programs on the computer. So this is how programs like Mumble, how programs like WSJT or any of those types of programs, Verimodem, can talk and send their audio up into the system from the computer to the hardware. Here's an example of the signal path from a user that's coming in on Mumble that is going to transmit. So you see I have a channel in here called From Mumble. So we fall down that channel, and you can see I'm sending through 2 outputs. Output A3 and output A4. Now A3 happens to be mapped. I know this, and this is how this is set up. A3 is mapped to input number 1 on the Mo2. So that means I'm falling out of mumble, coming out of mumble on the computer, hitting A3, and then A3 is telling you what, send that audio to Mo2. And where is it going from the Mo2? It's going out the Mo2 into the DBX, into the Optimod, into the analog input of the radio. That's how we route that audio there. Here's the other path. Let's say we're listening. The user is, how do I get audio back? I'm sitting at home. How do I get audio from the radio to mumble? I have a channel, an input that is the radio audio, the line out of the radio. Coming down here, I hit a virtual output called B2, which is mapped down here, as you can see, to this channel that says to mumble. So now anything that's the radio audio comes down, hits this, and is sent to any mumble user, right? That's kind of the input and output. That's how we're doing stuff like this. And by toggling these different buttons, which they're saved in memory now, they don't have to be mucked with, you can do things like have that mumble user not be heard, at the station, or I could block that application, for example, from Windows here. This channel. Let me just pull up my little annotation. Whoops.
From Windows is the Windows box. It's on the
correct.
That's on the table there.
Yeah, okay. I'm just trying to get my thing going. So from Windows here is any Windows sounds, right? I don't want to have CNN's latest story playing over the air, right? So down here you can see that we are not sending that to A3, which is the radio audio. That's unchecked, right? So that's the flexibility that exists in this. And like I said, all this is defined in a profile that set and forget. Once you got it set up, it's done. So
if only the guys at CK&W could do that.
Oh,
because I hear the little chimes, the Windows chimes.
The Windows sound.
Yeah.
Okay, now the audio back to the user has to get into Mumble. So we're coming out of that virtual output in voice meter, and inside the Mumble software program, which is what I'm showing you here. Oh man, this is brutal. I keep mucking myself up with this. So in the voice meter output, we have a ability to select in Windows. It shows up as different inputs. Rather than a microphone input in software, it shows up as a virtual input. I can use that. So normally you would tell Mumble, hey, I'm using a headset. Use the microphone on my headset as the input. In this particular case, I'm saying use the virtual microphone coming from voice meter. So I can use that to route the audio through. I touched on this already. I won't belabor it. This is the BearX box. All that to say that this is what it looks like from the audio archiving perspective. So there's a web page that's publicly accessible, and once you go there, you can see the 4 or 5 days of look back, and then these are the chunked 50-minute recordings there that are on the right-hand side. I can go into any one of those and play them on a computer or phone.
I've relied on it several times when working from home or whatever, and I didn't record it, and I said to myself, geez, I wish I had that recording. I come in, and it's time-stamped, day, date, time,
Yep.
Download it.
Exactly. I've used it numerous times when there's a rare station on. I talked to somebody in the South Pole at a research station, and people at work, I was telling them they didn't believe that was possible, right? So here's what it sounds like, right? Here's the recording. I talk about Mumble quite a bit. This is the program that we're using remotely on laptops or smartphones to get our audio to and from the station. It's the one that checked all the boxes in this list. Mumble's, again, cross-platform. It's open source and works really, really well. This is what it looks like. Basically, again, you're given the ability to select your input and your output. On the left-hand side is your your audio input options. You can say I'm transmitting on a push-to-talk mode. I'm continuously transmitting my audio to the remote station. I can change my level of quality here, my bit rate. I can remove my noise suppression, which is critical. And then on the output here, you can actually see we can deal with jitter buffer. So we can actually disable jitter buffering or have a little bit of jitter buffer. So if I'm on a really crappy cellular connection, I can increase that buffer and I get a little bit more latency, but I actually have some recovery. So that's what the interface looks like. Now this is a cool little test I did actually last night. And it answers the question about, well, how far are we from the real world here? So the test scenario here is we have an analog AM radio receiver, right, which is speed of light, old school. That's your baseline. And then what does an SDR add to that equation? So a non-SDR receiver with the current filtering we have set up, and this would be not much different in a flex radio, it'd be pretty similar, 133 milliseconds behind that baseline. So you're 130 by default, sitting in front of the radio at the computer there in position 4, listening to those speakers, you're 133 milliseconds behind what's happening on another analog radio. That's the disadvantage of an SDR. Okay. And then what happens if I'm remote at home? The internet gets involved and it adds its delay. And I had a worst case example last night where I was testing this over a cellular connection. And that added 87 milliseconds of latency in addition. So it's not intolerable. Like, 200 milliseconds thereabouts is perfectly fine. At roughly the rule of thumb is around 150 milliseconds. Two-way conversation on a telephone becomes problematic. But on radio, when we're doing push-to-talks, half duplex, it's really not a big deal. It's not a problem at all. Here's how I tested this. I think you'd find this interesting.
Vancouver, a Chorus Entertainment
So
station
what I had is an AM receiver,
CKNW.com.
and I had that hooked up to a microphone. Here's the Anan, tuned into CKNW as well, and you'll see that zoom in here. So I did all this at the same time. I set the 3 microphones up and I recorded them in 3 places. So right in front of the speaker is a little microphone turned into a wireless transmitter. These transmitters introduce negligible delay. They're like 2 milliseconds of delay. And then here's the laptop on Mumble listening to the same feed with the RE20 sitting there recording that into my mixer. And everything was feeding into my mixer, and you can actually see the faders fade in sequential order with the delay. So the actual way that looks like on the screen here, you can actually see the incidents. There's 3 tracks I recorded: the over-the-air example, the Anan example, and the Mumble example in 3 tracks. And then I think the next little clip here shows you what that actually looks like. You can actually see the same waveforms, but just slightly decayed, right? So, and that's how I got the numbers. I just zoomed right in and I made some notes here on the baseline. So that is an example of the kind of latency you're dealing with here and how I measured, real world baseline versus down the chain. Any questions on that?
Is Mumble free?
Yep, absolutely. Mumble's free. It's open source, so you can download it on your phone even. Android and iPhone support it.
And that's how Roly's audio is getting back
The
to
station.
the Anan when we do remote with him.
Yep.
And you have the ability to talk to Roly in his headset without it going over the air.
Because I can mute myself on position 4, so my audio doesn't go over there, but I can prompt Roly in his ear, which was one of the things I mentioned in the list of basically an IFB interruptible fullback. I could talk to Roly in his headphone and give him cues about things. Hey, your framing is off, or your video, or you're too close to the mic, or whatever, and he'll only hear that. It won't go over the air. So that's cool. That's the practical latency example. But what about if you're just doing this over BC Warn? Let's say you were at the North Shore Club and you were wanting to remotely control our radio. The delay gets even less, and it's really cool. I did a test a few years ago, and I'll have to turn up the volume a little bit here in the room to hear this. The delay I'm showing you here is, or the video I'm going to show you is what this is. Basically a radio at Mount Seymour at the top of the screen, top left. That's a K3 that I physically put at Mount Seymour on a real antenna a few years back. And I put a remote head of that. In fact, maybe Phil, you can grab the bottom of that radio. That's nothing in that radio, and just pass it around. This is the remote end of the K3 radios. It's basically a hollow enclosure.
We used this at the EOC a few years ago.
Yeah, exactly, right? So this is the front panel, display only. There's no RF in that. So I put that at the club, right next to the club's K3 as well, so that we could actually see on the same frequency what the delay was like between the receiver on Mount Seymour, which we had on a dipole, and the 80-meter dipole down here. And I'll play that audio for you right now. And it sounds like a speaker that's just slightly down the hall. So this is the path it's taking, by the way, just Mount Seymour to over about 21 kilometer microwave link to Concord in Surrey, and Surrey over to us here on BC Warn. So it's 2 hops. Okay, some folks were asking here about the dual radio setup at position number 4. And of course, this is the Club K3 here. This is actually the remote head for a K3 up on Mount Seymour, my K3, which has been installed in a rack up at RPT and is connected to the club here via BC Warn, or anywhere for that matter, but its remote head is here right now. So this is just a fake radio. There's nothing really in this box. The remote interface is here.
So what's interesting about this is a different perspective, especially for ground wave stuff within the lower mainland. Right now we're listening to the Aurora net here on 40 meters. And net control is VE7 GBO Todd over on Vancouver Island. And so from here at the club, we have a hard time hearing him, even with the quad pointed towards Vancouver Island on 40 meters. Mount Seymour, not a problem. Ground wave.
That's the remote radio.
So this guy's in Langley, and he's roughly the same signal strength on both radios. 5.9 plus 15 or so. We, of course, are hearing the DX stations better here than at Mount Seymour, better antennas.
Do you have any traffic, sir?
A little bit of echo? That's the delay.
All right, good evening to you as well. Light copy, but I got you in there. The afternoon Aurora net is looking for further stations. Anybody east of Alberta?
Let's just get a little bit of reverb.
Looks like I got one there, Andy.
Yeah, that's good. Thanks, Sean. V4 Lima Golf, Todd.
A little noisier up on Seymour.
Oh, okay, thanks very much for that.
See Todd.
Thanks very much. Yeah, thanks, Sean. Good afternoon to you there, Jake.
Can barely hear him.
Mention that. I said that's got to be Jake.
Loud and clear.
Thank you very much for that. Okay, the afternoon Aurora net is now moving into.
So that's the demo of like on the network, over a wireless network with like 25 kilometers of distance and a couple of routers in the middle. That's what you can. That's about as tight as you can get it. And that's, like I said, no different than putting the speaker slightly down the hallway. It's pretty impressive. It's about maybe 15 milliseconds of delay. So that brings us to the next set. Any questions on that, by the way? Any online as well? Any questions? Somebody, Roly, did you have something? You must have.
No.
Oh, okay, fair enough. Any questions, guys? Cool. Okay, so the next section here is about microphone and codec. This is really short, but I wanted to just highlight the fact that when you are a remote person coming in from home, and this is I think partly to blame. I'll call this the Zoomification of audio. Used to be that for example, in the radio world, if you called into a talk show and you were on a speakerphone, you didn't make it to air. Right? It would be get the hell off your speakerphone, dial back in on a landline, talk radio. You just wouldn't get put on. Now every day, even the hosts are coming in over basically a Zoom conference, and it's the audio quality is atrocious. People have gotten so used to a microphone that is in the laptop over here, and not one that was like when the telephone was invented. The microphone's right here, and so the audio quality, and of course on any radio that we've ever used, HF radio, VHF radio, you got a hand mic. You're element to an inch away from your voice. So you're always close talking things. And now we've got remotes that people are experimenting with using their iPad, and the iPad's on the table. There's the microphone right against a hard surface down here that's reflective. It just sounds like terrible. So here's an example of what the difference in audio sounds like if you're using an integrated mic in your laptop versus a headset.
Some people think they can use the integrated microphone in their laptop for remote HF communications. And this is what that sounds like. A better solution is to use a USB headset. This is what I'm using right now. This is a wired USB headset, dual ear with a microphone on a boom arm coming right down in front of your mouth. Sounds a lot better, doesn't it?
So that was recorded in a room that has acoustic treatment.
I would say, though, I think you were getting higher frequencies out of the...
Absolutely it was, but on HF you'd never hear that, right? If I was on a Zoom call, Neil's actually using the same headset that I recorded that on, which is this. And this is a cheap headset. This is like $60. It's probably the best wired USB headset for voice quality and noise reduction that doesn't sound like it's doing noise reduction. There's a lot of headsets that sound, especially wireless headsets, I would stay away from that world altogether. Bluetooth is just the codecs that are in use, and a lot of these just don't sound great at all. And that becomes back to one of my other points, which is being indistinguishable between being at the station and remote. If you've got a totally different sounding microphone, we can't make up for that despite all the processing down here. Okay, so microphone selection is critically important. If you're doing any kind of remote, you want to be on a headset. It's also really, really important because we don't have any echo cancellation that you have headphones on. You can't just, I could certainly listen to the radio all I want with the speakers open and everything, but if I'm going to start talking, I need to put on a pair of cans, right? Because otherwise you're going to get into a feedback loop. Now, The next thing is codec, and this is kind of cool. This is where we've come a long way in telecom in the last 20 years with regards to the processing power and the standards where they're at. So all web conferencing like Zoom and Webex and everything moved about, I guess 10 years ago to Opus, which is an IETF, Internet Engineering Task Force standard for audio over IP. And Opus can do quite well even at 16 kilobits per second. The convention in telephone circuits over the last, since the 80s, early 80s into the 90s has been 64 kilobits PCM, right? So G711 generally with the PCM encoding and behind the scenes. And 64K is not a lot of bandwidth today, but that's a fixed bit rate. And you can actually get this down to 16K and sound it pretty good. Here's what it sounds like. Starting at 8K and working my way up, and you'll quickly see it's diminishing returns. You're listening to an audio sample here on Mumble at 8 kilobits per second. Testing 1, 2, 3, 4, 5. You're now listening to an audio sample at 16 kilobits per second. 1, 2, 3, 4, 5. You're now listening to an audio sample at 32 kilobits per second. Testing 1, 2, 3, 4, 5. You're now listening to an audio sample at 64 kilobits per second. Testing 1, 2, 3, 4, 5. This is the PCM crossover for G711. And now this is 128 kilobits per second. Testing 1, 2, 3, 4, 5. You can really only see the difference if you start looking at this in a spectrum analyzer, and if you are looking at, like, for example, a CD quality type of source or better, right? Music playing over this, but the big thing is not necessarily the human voice that's the problem. I alluded to earlier, it's the static going back to you as the remote user. Being able to hear a signal in the static, you really need to be at 32 kilobits or above. 16 the signals become mushy and hard to discern. It sounds like really crappy DSP, right? So we run Mumble here at 64 kilobits per second. We can run it down. I've run it on some of my phones, like mobile, at 32K. The guys on the other end won't notice the difference because it's HF and we're running a narrow channel. But it's the other path. It's kind of nice to have the higher bit rate. Okay.
Does any difference in latency between different codecs?
That's the cool part. Okay. And Opus does the best as all the codecs on jitter. Its concealment and jitter handling is just awesome compared to the other codecs.
So in this case, jitter would be like a lost packet?
Yeah, jitter, lost packet, or interframe delay in packet transmission, right? Okay, this is the kind of cool part here in operation. So I'm just showing you an example here. I'm going to just see if I can
At the tone,
turn this down a little bit here.
43 minutes.
This is the, can you hear me okay talking over top of this, Neil, right now? Thumbs up if you okay. Okay, awesome. So this is the remote desktop that I'm showing you as a user from home. I'm dialed into WWV here, just like I'm sitting in front of the real radio. And I'm just, you can see me playing with the filters. I'm dragging the filters left and right on the screen. I have on the bottom right-hand side, you can see the quad selection. I'm actually able to switch the different bands of the quad here. I'm on 40 meters right now. I'm now down on 80 meters. I have the antenna rotator on the top right, so I can see where the T2 rotator is pointing, in which direction it is. And on the bottom right-hand corner, I have my eyes on the audio mixer. Not really important, you don't need to because that's at the far end, but let's say Phil was at the station and he wanted to talk to me, or if we wanted to check into the net together, something like that, he could come in and unmute his microphone, and I'd want to make sure it's muted after he's done talking.
This is 32 kilobit?
Yep. So I'm just bouncing around here. That's what the user interface looks like, right? This is it in a nutshell, right? I'm running noise reduction here. I got this is more of an operational thing on Power SDR and Thetis, the software that's running here, but the noise reduction is pretty cool. This is a station in Italy on 40 meters the other night. Yeah, he's H9 plus a little bit, and you can see the difference that switching antennas makes. Right now I'm going to switch off there to the 80 meter dipole. Gone. Can't hear him anymore. Switch to the quad.
So you remote desktoping to the screen.
Yep.
If you move your mouse right now, we'd see it moving.
See it on this. Yeah, exactly. Fully remote. And that's cool because somebody that's at the station can see that the station's in use, right? And so there's a bit of two-way there. But that was kind of a multi-purpose little demo there. I wanted to show you the analog little meter that is an add-on there to the software package, which is kind of cool. The rotator, you actually, if you really paid attention to that in the recording, the station when he came on, I had the quad facing east, and then station from Italy, so I moved it up towards Europe, and the signal came up quite a bit, right? So all this kind of stuff that, you know, just, it's like sitting in front of the real radio. It's no different, in fact, right? Which is why it's so cool. Now, there's other cool things you can do. This is kind of getting outside the bounds of traditional operation, but this is an example of taking a Zoom conference and patching people on Zoom into the air, on the air. So in the New West Club, Jeff Armstrong, VE7KA, went on vacation a couple summers ago to the Mojave Desert, and he took down his HF mobile. I was joined to the New West Club meeting from home. And the guys at the New West Club have a station there, but they don't have a good station, right? It's an inverted V on a 60-foot tower in a relatively noisy location, unfortunately. So they said, could we talk to Jeff? I'm like, absolutely. So I remoted into the club station. Jeff, we coordinated with him via the internet because he was on, and we said, what frequency are you on? Dialed him up, and this is what it sounded like. Me taking the guys at the New West Club and patching them onto the radio so they could hear it in real time. A quick demo to Zoom for a bunch of people to check you out there on HF. I don't know, Kevin, if you're on the line, you want to give Jeff a call, you can come off of mute and give him a buzz there, ZZT. I'll let you have the frequency in a second here. Go ahead, Kevin, you're on the air.
Hey, Jeff, V7 ZZT to V7 Kilo Alpha through the VE7 SCC radio station. You sound really good for a mobile from way down south. Oh, back to you.
Yeah, QSL V7ZZT from Victor Echo 7 Kilo Alpha stroke Whiskey 7 portable. Yeah, you're sounding really good as well, Kevin. I'm about an hour's drive from the Mexico border here in Arizona, so yeah, you're making the trip really well.
And I take the helm of BC. Anyways,
Charlie.
Yeah, I'll make a call.
So Matt talked to him next. It was Matt, I think.
Yeah, Roger. Victor Echo 7 Kilo Alpha portable Whiskey 7. Here is Victor Alpha 7 Romeo Oscar Hotel. How copy?
Victor Echo 7 Romeo Oscar Hotel.
You get the idea. Kind of cool being able to take people on Zoom. I can see, for example, applications in emergency management where you have somebody in the field with maybe limited SATCOM and this capability where you have people that have internet connectivity that could be on a Zoom call, and you could patch this to literally hundreds of people on the line at once and have them listening in and selectively unmute people to bring them on to talk on the air, which is kind of cool. It's like a really glorified.
Zoom for the audio, or we?
Yep, that was all Zoom.
That wasn't even mumble.
That was just Zoom. Yeah.
Wow. They sounded pretty good. I mean, they.
Yep.
Just for Zoom, like when we were hearing their audio, it was like,
yep.
That sounds pretty good.
Yep. So this was a mix of, and I recorded it for longer, it was a mix of people at the New West Club and other New West Club members who were at their homes that were part of that meeting, and then we patched them all in. And because we got the kick-ass antennas here, the big quad on 40 meters, like we were blowing Jeff out of the water down in the Mojave Desert. He was like 20/9 down there, right? So now this is cool. This is the old school. So we did a glorified phone patch. How about a real phone patch? So phone patches, for those who are not familiar. Did you have a question, Phil? Or
I miss those days.
No, the old phone, the Autovon phone behind the blur here. So a phone patch is connecting your radio station into the phone system, the POT system. Historically, very very common back in the day for patching on HF, but we don't have a way to patch a phone hybrid and analog line into that radio very easily. But we have a voice over IP client on that computer. We have microsip, which I mentioned before. I have a voice over IP account on a phone number associated with that account that is constantly running on that computer. So here's what a phone patch sounds like.
Hi, good afternoon. This is the shack of Victor Echo 7 Kilo Juliet Romeo, and I am on a landline here connected to the ANAN radio at position 4. Just doing a test to see what the quality is like. The landline is actually on Vox at the radio Kilo Juliet Romeo testing. Over, out, and clear.
You're listening to this, Mike?
So that was
No, I
recorded.
wanted to know where that,
That
was
was recorded in Prince George on 80 meters.
It was on the air.
Probably about, yeah, that's an over-the-air recording. So we transmitted on, I think, 3.66 megs. And I fired up the SDR in Prince George at Frank V7AV's place, hit record up there, and that's what Phil sounds like when so I called Phil from position 4, remoted in, dialed using the phone patch.
My phone rings at home.
Yep.
Was that a landline?
Yeah.
So it wasn't even an HD call.
Yeah, that's correct. Yeah, it was to his.
That sounds better than most nets.
Correct. Exactly.
I'm getting rid of my fancy microphone at home. I'm going to go with one of these.
Just phone it in, and it sounds great.
Key right there.
I'm going to just because I'm going to show you this real time because I think it's pretty cool.
I think we still have one of those phones in Prince George.
Probably.
I think it's a
rotary. You okay with your phone number?
Yeah, sure.
What do you
604-783.
Hang on, 604. And I'm going to put the receiver up on WWV here just so that we got something to listen to. And let me hit the call button.
Okay. So
Here, Paul.
Standard call.
Put it on speaker.
Oh, put on speaker. Yeah, I was right with that.
How come? Oh.
Yep. Okay, there you go.
There you go.
A little feedback there too.
Yeah. Well, I think if you hit the mute button on there. Yeah. Anyways. Impromptu demo, but yeah, the feedback wouldn't be there with normal circumstances. Yeah. But that's the deal. Yeah. I mean, this is a backup pet plan for Roly, for example. If Mumble fails, we could dial the cell phone and have him run the net over the cell phone, and the latencies on the PSTN is pretty decent, right? You're pretty tight tolerances there. So that was just me signing into the remote here real time. I'll go back to my presentation and we'll wrap things up here. And this is kind of the cool part. And Roly's aboard his boat there. So we've been, as you're probably well aware, I guess this is now probably our 150th or 160th time we've done the BC Net out of the club because we do it every Wednesday for the last 3.5 years. Roly operated it. Maybe Roly, if you can come off a mute there, you can tell us a little bit about what you were doing originally at home with when your wife was laid up and what you're doing now.
I'm trying to find the mute button here.
Yeah, you're good. We can hear you loud and clear.
Okay, can you hear us now? Hear me now?
Absolutely.
Okay, good. Yeah, I've lost you. Nonetheless, well, yeah, there was a time in my life when things were critical at home and I had to stay close to my missus, who I lost last December. And finally, she succumbed to the kidney failure. And there you go. But at that time, Ian and Phil were kind enough to let me stay in the shack and be on call, as it were, down the hall. And so, yes, I was able to, back in the day, remote into the club and do the net from there. So that was the beginning stages of remoting. And then, of course, now I have bought a boat and I live on the boat. And I'm down at Milltown Marina. Near the YVR here, and I sit aboard in the pilot house here, and Ian and Phil have been in here now a couple of times and set up cameras, lighting, and various other pieces of electronic equipment, which I like a lot. And we've tried different telephones, and there's a shot of me with a fabricated desk in front of me. And as you can see, that's the front of the Alcan 37, my boat, and I call the pilot house So with that, I can just say that it is working very well from here with my wireless router. I am with Rogers, and I switched. Of course, I'm not. I don't have any physical contact with the land, so I got a Nokia 3415, I think it is, wireless router. Ian came down with all his test equipment, set up, and did some measurements from up at the Safeway above me here, about a block, and then over to Airport Tower, or whatever it's called, the Airport Square, and there's antennas up on that. And I'm not sure which one we're actually getting the good signal from, but I'm getting a couple of bars out of 3 bars on the wireless router. So that's a quick review from me. Go ahead, Ian.
Yeah, absolutely, Roly. And so it's wireless, LTE, which is not good in the best of days, right? It is at the whim of the public demand on that service. But most importantly, for Roly, within his boat, it's a wired connection, and that's something to highlight. He's in a marina with tons of other people on Wi-Fi, and so if there's going to be something that's going to be intermittent and introduce packet loss in that environment, it's going to be the Wi-Fi connection between his laptop, or how he's remoting into on Mumble, and his router. It's that 10-foot, 15-foot link, literally from that screen you see there. We ran a cable above the window, just behind the camera, to where the router sits. And without that, you can actually hear the packet loss on the Wi-Fi. Because again, there's very little error correction. This is all UDP. Frames are being sent. Voice over IP is very susceptible to packet loss. And so where possible, you want to rely on wired connections, at least LTE. You have your time division duplex, and so you're not doing contention avoidance like you are in Wi-Fi, which is a challenge. So this is a picture of the setup there, and in addition to Roly operating remotely using the screen that you can see, he's got it up on the screen there in the background. We're also live streaming to YouTube from the boat now on Wednesdays, and so the camera is hung from the ceiling there, which is fully remotely controllable. This is completely unrelated to the topic at hand, but I thought it was kind of interesting to talk about. And this is an example of what that looks like, from a framing perspective. Again, you couldn't do this kind of thing with an analog radio.
Kilo portable 7. Good evening.
So you can see in the top right-hand corner, I've got the pan adapter showing from the Apache Labs radio. I've got the S meter overlaid with him, and I've got his audio, synced up there and synced up with the radio audio, so everything's lined up in time domain. It's pretty cool, and you can see we typically have there's 142 people that have watched that one replay, right? It's pretty cool for just the little, and you know what? People are on the BC net that listen to that. They use it for signal report and check-in, and they can double check how their transmitter sounded, and it's kind of a log, if you will. At the very beginning, I think this is near the end here, but at the very beginning we talked about signal clarity and cleanliness. And this is some pictures I took from my cell phone just monitoring one of the Kiwi SDRs a little while ago. You see an example here. This is Roly actually running his net, the Christian Fellowship net that he does on Wednesday mornings, early in the morning. It's on 20 meters. You can see the other guy's radio, and then you can see Roly's radio, and you can see this is time left to right. You'll notice the guy the guy on the left. He's actually running. If you look at this, I just bring up an annotation here. You can see where his receiver transit bandwidth is set for. Is roughly that region there. The challenge is you got all this spurious that's taking you out, almost double your actual width. And when you factor in all this garbage that's happening here, that is completely absent when you have pure signal running on the Apache radio, despite the massive amount of audio compression that's taking place. And that's a real feat to get that level of cleanliness in signal. It's literally a brick wall. You can snug right up against our signal, and we could be 40 over 9, and within a kc away from us, you won't hear us, which is pretty phenomenal. You couldn't do that 10 years ago with amateur equipment. So I don't know, Neil, if Flex has made any further progress on their pure signal or adaptive pre-distortion. I know they were also talking about doing this as well. If you have any commentary on that.
Yeah, it's not available yet, but built into the Flex is CSSB, so
yep.
It's kind of part way there. Let's put it that way.
Yep, absolutely. So I think that's where I wanted to more or less leave off here, was just kind of that little bit of an example. And the little bit of a wish list that I have I'm adding to here as we go through is, because it's an SDR, that 133 milliseconds of delay works both ways. You know, on receive, I talked about the 133 milliseconds of delay from the real world to the receiver, to the speaker. Well, it actually works in the opposite direction. So when I'm transmitting, I speak into the microphone, or I'm coming in over a mumble, I modulate, and what comes out the other end is 133 milliseconds delayed as well, because it's got to go through the DSP and the filtering and the radio. And so it's a little counterintuitive, and I think with some higher performing FPGAs, this problem will become less and less of a thing over time. There's already a second generation of this radio architecture out, which would be very interesting to observe. One of the things that would be nice for those that have two monitors at home is the ability to run the radio across two monitors. You can do that only in the paid version of Parsec right now. And so, for example, let's say you want to have your logging program up on one monitor that's at the club, or you want to have a bunch of antenna rotators up and stuff happening on one screen, and you want to full screen the radio on another monitor. You can actually remote desktop 2 or 3 monitors through Parsec, but it's on a paid plan with them. So I think it's like $8 or $10 a month. It's not crazy, but it's just something to be aware of. We've been doing all this work with Roly and all my remote, and I'm focusing on voice here because CW, we'd have to generate all that locally. You cannot send CW over the internet reliably without a lot of delay to make up for packet loss. But one of the things we've been doing is using all this via Vox. And one of the cool things that this architecture of SDR has in it is a look-ahead window, about 15 milliseconds. So all the audio that's coming into the radio is buffered, and the Vox is triggered based on the look-ahead window. So traditionally, if you've operated Vox on a radio, it has a tendency to clip the first syllable of your speech, and it's very evident to somebody on the other end of the radio that there's Vox being run, and you hear this, like it's cutting off that first 10 milliseconds. Because there's this buffer that happens in the ANAN, it is able to key based on past knowledge, right? And so you can run Vox in the ANAN radio, and we do, all of the nets that Roly does. You cannot hear it working whatsoever, which is phenomenal on the other end of the radio. That's another big plus for this architecture. The downside about this is sometimes I'd like to operate PTT. So the way I've been working around that in some of the situations is I've been using mic mutes, like this particular one here. If I don't want to talk, I don't want this mic to be hot, I just mute the mic in software. Or I push this button, the microphone is muted. Nothing can get onto the air. What I'd love to do is use like CTCSS encode. Yep, so in-band audio keying, basically. Give me a low frequency, 20 hertz, 50 hertz tone that I can notch out at the other end. And that way it would do that. You'd have to have a bit of a latch on there so that it would not bounce. Because packet lossing, you might bounce your keying. But that could be something that's done like that. The other way to do this is using like contact closure logic remotely. And that's all possible, but it's not something that is built into Mumble as an example. Calendaring, so when we talk about the challenges associated with running this widespread in the club, there's going to be probably demand for this. We've got a better connection in here now. I suspect some of you may want to play around with this. How do we calendar remote operation? How do we make sure that we aren't colliding with people that are out on the station here in the club who may be operating on some of those antennas? Access to the surveillance cameras so you can see who's in the radio room and maybe phone the station if you need to. And the last thing that's on my wish list right now is the antenna switch that Keith built for the T2 quad is all Raspberry Pi based around Node Red. I'd love to have that tied in with automatic frequency following using a more modern protocol that's becoming popular in a lot of the radios and the SDRs called TCI. And I think it's called Transceiver Control Interface, if I remember correctly. And it's basically an API. It's an IP-based protocol that allows you to send all your radio stats modes and everything back and forth in band data so that you know what frequency things are on. And Neil's already got that working on position 8 with RS-232 and the matrix of things that they do there for the band switching on T1. I think it's just the next step for us to do this on T2 so that you can change between 80, 40, 20, 15, and 10 and not have to dick with the antenna switch. And it also prevents operator error. So I think that's it. Any last questions?
Maybe add to that list matrix?
Matrix. A switch matrix.
Yeah.
Yes, there's a whole other page of this to get there. But yes. Yeah, absolutely.
Congratulations. Ian, that's a very impressive presentation and a hell of a lot of work you've done.
Yeah, it's been years in the making as far as putting all the bits and pieces together, and I think we're finally in a position where it'll be more and more reliable moving forward. It's been a bit of a science experiment to getting to this point, but I think it's pretty much mainstream.